Is it line graphs? Yeah. Yep. So next we have line graphs. This topic is very easy. What's that? Something what? Electron? I don't know.
Yeah.
What are you talking about?
No, I remember the names for it.
What are you talking about? Lipton? What?
Names for the graphs.
Names for the graph? This is just called a line graph. It's as boring as that, I'm sorry. Line graph. Now, number 1, this is on the syllabus. Number 2, this has not been on the exam. So, it means that it could be on the exam, but it hasn't been. Now, also number 3, the syllabus is changing next year. I got the new syllabus last week. So let me just say you're quite lucky that you're doing it this year, not next year, because the new syllabus is a lot bigger. So this makes me feel like, since this is the last exam of this syllabus, and this hasn't come up, it would, well, no, because it would mean that they didn't put this in the new syllabus, which makes me think that they realised that there's no point in asking people to do this because they've never asked it, you know. So I don't really think it will come up, but it's still useful because the next graph we will do, which is on the exam, is very similar to this graph. Okay? So for a line graph, what do you need to know? Well, firstly, yes. Yeah, I hope you can draw a line. Yeah. Firstly, line graphs, it's data for quantitative that changes with time. In fact, you don't realise this, but you've done line graphs already. In biology, when you have, well, I don't know actually in biology, do you ever have time on the x, or was it only temperature? Time. What unit? Seconds, yeah? So when you have time on the x-axis and your data on the y-axis, this is actually a line graph. We have not done this in physics because we had on the x-axis, you know, like voltage. Yeah, well, for a question, yes. In the experiments, no. But you're right. In physics, we've done time velocity graphs. And these are actually line graphs also. So in other words, for a line graph, you need your data to be on the y-axis, and you need your time of the observation on the x-axis. So firstly, it'll look something like this, for example. So what did you do in biology? What did you put on the x-axis? It was time in seconds, and what was on the y-axis? Temperature. Yeah, but in this example, when you had time, what did you have here? Yeah, so what did you call that? Just activity, or speed, or velocity, or? I'll just call it activity then. And what was the units?
Something related to volume.
This is not what your biology teacher would want to hear. That a column's actual word, something to do with volume, goes on the y-axis. No? Milliliters? This was the experiment where you measured the volume of the bubbles or something, or the foam. Yeah, okay, then milliliters then. So at different times, yeah, you measure different volumes. Yep. Okay. And then, like for physics, an example from physics would be, as you said, Abraham, you have velocity on the y-axis in meters per second. And then on the x-axis you would have time in seconds. Now, what you'll notice with a line graph is, well, it should be your data plotted as points, and I think with the Emzyme one it'll look like this. It will increase, but then it will decrease, something like this. And maybe for us in physics, if you were dropping something that fell to the ground, it would get faster as it falls. So maybe our graph could look like this. Something like this, okay? So some things about the time velocity graph. Again, it must be, the line graph, there must be time on the x-axis. Also, you plot the data points. Like this. And then very importantly, you draw, and this is very important, lines between the points. So when you say line graph, it means you have lines between the data points. So we'll do a nice example now. Yeah? Can I go back to office? Yes? Okay. Now, let's do something like biology example. So time in seconds. How long was your enzyme activity experiment? 30 seconds in total.
Or 60.
We'll say 60. And how often was each measurement made?
It's either 30 or 60.
No. Listen carefully to what I'm saying before you speak. How long in total? Omar, why are you talking in the middle of me giving a sentence that started with listen carefully? Why are you doing this? Why are you doing this? Answer this question or be quiet. Are you choosing the be quiet option?
Yes.
Good choice. So in total, how long was the experiment? In total? Thank you. 60 seconds. And how often were measurements made of the enzyme activity? Every 30 seconds. So you only made 3 measurements in total. 0, 30 and 60. That's all? Only 3? Really? Okay, that's not much then. So we'll use 3. So there was 0 at the start, and then 30 seconds later you made a measurement, and then 60 seconds later you made a measurement, and this was the last measurement. Okay. So what type of will have activity? Let me actually just call this T. An activity we're using milliliters. So what type of number did you have at the start for the 20. And then 30 seconds later, what type of number?
34 or 40.
35. And then later,
60, 70.
it's bigger again, yeah? So we'll say 60. Does this seem right? Hang on, it's okay. This side of the room doesn't seem convinced. What's wrong with these numbers? Are these numbers believable or unbelievable? Believable is all I want right now. I don't want accurate, I want believable. So these are believable then. Okay. So for the line graph, this goes on the x and this goes on the y. Let's have a look at what we should get. Line. And we want connections. Okay, now please do not forget in the exam you need a title. So this is, I don't know, biolab stuff. X-axis is time in seconds and y-axis is activity in milliliters. The heck? Oh, sorry, this is me being stupid. Go away. I forgot now that this is a bad program here. I just need to highlight this. Line.
The line is there.
Now don't confuse your poor tired teacher. Just give him a minute. One more time. Line, connected, X and a Y axis. This is time in seconds, activity in milliliters, lab stuff. Okay. Now, you'll notice that on my graph here, the time units are not correct. I'll have to fix that. I think I can. Oh my goodness. Yeah, I'm going to use Office. Let's first draw it by hand. Okay. Time in seconds, 0, 30, 60. What was the biggest number for activity? 60? So I'll put 60 here, 30 here. Okay, what was my first number? 20? So that would be here. And after 30 seconds? Okay, so that would be about here. Well, that goes something. Okay, and the last one? 60 also? Okay, fine. So, now, when you draw these, it's not a straight line through all of them, but it's a straight line from the first one to the second one, and then from the second one to the third one. So it doesn't have to be one straight line, it can be broken. Okay. Let's draw a nice one. What was it, 30? 20, 35, 60. No. You see, it's not even working now. Don't have any names on it. Alright, you'll just have to make do with my beautiful hand-drawn one. Yes. I'll do another one now. But just a couple of things to say about this graph. You don't have to start at 0. But if you don't start at 0, I'll show you what you need to do with another example, okay? So we'll do another one now. Can I actually go down, or I can go down? Yeah? Yes? Yeah. So let's pick one where the time doesn't start at 0. So I don't know. We'll do, I don't know, some physics one, velocity. So maybe this is the time at 60 seconds, 61, and 62 seconds, and 63. So the time doesn't start at 0. And also the velocity doesn't start at 0. So we'll say that it starts at, I don't know, 40. This is in seconds and meters per second. 40, 45, 45, 40. So we shouldn't start at 0, because if I start at 0, I'll have a big, long, stinking gap, and then I'll get to 60. And I shouldn't start at 0 here, because then I'd have a big gap and then start at 40. So our graph would be way up here. So this would actually be bad. Where should I start? on the x-axis. I should really start at 60. So the way I can show this, if I still want to start at 0,
with 60 on the base of the already.
no, not this, or 50. You still start at 0, no, you still start at 0, but you draw this little symbol to mean that you're skipping part of the graph, like this. And then here, this could be 60, 61, 62, 63, and this would be time in seconds. Now you can only do this once at the start, this skip. You can do the same thing here. And here would be 40, 45, and 50. And this one here is velocity in meters per second. So my first number is 60, 40, 61, 45, 62, 45, 63, 40. Let me put in some dotted lines. So now I join them line by line, dot by dot. So there's the first one, there's the second one, and there's the last one. So this is my line graph. And then this is my data. It doesn't look so bad. Do you draw that as neatly as this? Yeah, good. So please, again, I'll just say, these here, you can only use these once on each axis. It's once, and it's at the start, before you make any plots. Yeah. So don't put one in the middle here, or at the end. It always is at the start before the first dot. Okay. Now, in fact, usually in the exam, when they give you graphs to draw, you don't need to do something like this because the numbers are small. But just in case, you can use this. Alright. I'll let you work on those questions for a few minutes. Yeah, so 10 minutes. Draw some line graphs.